On the second investigation, you're going to look at position time graphs. You're going to try to match them. We actually give you a position time graph, and we want you to walk such as to match that. That is actually more interesting because, you know, it's a little bit harder to do. Now, after the first experiment, for example, let me look at this position time graph. Let's see if I can find it. It is called, let's see, it must be investigation 2. There it is. Matching one. So now I go in here and I say open, and again I'm going to open an activity. I don't want to save anything. I go to find Physics 203 in here under Teaching Labs. I click on 203, and this is going to be position match. Gives me the numbers, and there it is. That's what I'm actually going to try to match. So you see down here it's constant. This is now position along this way versus time. So for a few seconds we're constant, then we start walking, and we're at rest again, and we walk at a different speed, and we're at rest again. And this is actually for 26 seconds. It may vary, you know, in your lab what you do. So you do that experiment, but this is harder than it looks to do this. And a lot of students actually like to stand in front of the computer screen and look at the computer screen and try to match it. I don't think that's as much fun as trying to remember, you know, that you are at rest for 10 seconds and you walk for 2 seconds and so forth, but whatever works for you. Then the third investigation, we're going to do velocity. Now this thing doesn't actually determine velocity straight away. What it does is it's putting out this sound signal at a high frequency, and it interpolates between the position. And by interpolating between every two positions, and it can then get the slope of that to get to the velocity. So Data Studio, the computer, will be able to determine a velocity versus time graph from that. So you're going to make some graphs with the velocity time. You're going to try to match some graphs with that. Matching velocity time graphs is extremely difficult. I don't want you to spend a lot of time on that. It's almost impossible, because it turns out to do that, because it turns out when we walk, we have a certain gait. You know, when you're actually stepping, you do walk, but when you put your foot down, you tend to slow down. Well, I won't spoil this for you, but it's really interesting. And then we're going to relate position and velocity time graphs. So we can actually compare position graphs with velocity graphs. And for example, we're going to find the average velocity. There are several ways you can do that. You can actually look at the position versus time, the points. Data Studio has something called a SMART tool that you can use to go read off all those points. By looking at 10 points, you can then determine the average velocity. Or you could find the slope on a position time graph. The slope, remember, of position time is velocity. Or we have statistics tool on here. You can find the mean or the average value over a particular region. And then finally, you can also do a fit. You can do a linear fit of the position time graph. A linear fit would give you an equation y equal mx plus b. The m then is the velocity. It's a slope on a position time graph. So there's 4 different ways we have you do that. And then we go look at acceleration. The acceleration graphs are very jumpy because the acceleration data comes from interpolating between the velocity points. And see, by now you've now done the second order interpolation. And quite honestly, sometimes the acceleration graphs really do oscillate quite a bit. We actually have an average function that we put into Data Studio. But let's see, now to do the acceleration, we're not going to have you walk. We're actually going to use this track. This is a 2-meter track. And now we're going to take the velocity, we're going to take the motion detector, has a nice means to clip on the end of the motion detector. And I can hardly reach over there. Maybe. Obviously, that's why we use teamwork to do these things. So that clicks right on the end of the motion detector, and now you have to level the motion detector. This is going to be the cart that we're going to use. This has fairly, you know, friction-free motion. So you start it actually moves with very little friction. But you have to level this, because if you're going to look at acceleration, you basically want the cart, when it's sitting up here, you know, not to start rotating. Well, there are 2 legs spread on the 2-meter track, and you can adjust these legs such that when you put the level on the track, it's level this way. You also want to level it this way. Now, obviously, the groups of students that come in the first part of the week hopefully will level this, and it won't change, but we'll see. You need to check this anyway, okay? Make sure you always check it. Okay, so then the motion detector is going to it's actually going to send out a signal, hit this device, send it back, and you're going to get you're going to get position graphs, velocity graphs, and acceleration graphs. And again, I don't want to spoil it for you, but this is really pretty straightforward. Then you're going to go through and find the average acceleration and those kinds of things as well.